everyone, my name is Errol, and this is Planetary Television. The natural instinct of human beings is to look over the horizon and wonder, what is there? Now, if we were to relate this to planetary exploration or any type of interstellar exploration, the first thing that might come to mind, in addition to our natural tendency to want to look beyond, is how will we get there? Currently, there is no technology that allows us to move, and have faster than light travel. Nor can we develop technology or even have the fundamentals to be able to develop a Einstein-Rosen bridge. So, at this point, there are only a few possibilities that's going to allow us to be able to have flight farther out of our system, of our solar system. And one of these discussions that has been raging for quite some time is the ability to use a solar cell spacecraft. It's the same concept that literally is the defining mission for the Planetary Society. The Planetary Society is the largest publicly funded space interest group in the world. And the idea of a solar cell spacecraft, a craft that is literally pushed by the pressure of the solar winds, literally pushes it on forward, just like the wind, the normal natural wind on the surface of Earth pushes a normal ship. Back some years ago, Cosmos 1 had been launched and was the first launched solar cell spacecraft. Unfortunately, due to malfunctions, the mission was not a success, but over the years, a new mission had been developed. The mission, designated as LightSail-1, has recently undergone a successful critical design review. And every so often, I like to feature these news articles from the Planetary Society, and in this instance is one written by Lou Freeman, and it's something I like to share with you guys. It's a very momentous situation in the development of the light cell, because this allows the developers to now move on to the next stage of development. This article was originally published by Louis Friedman on June 25th, 2010, and can be located at the Planetary Society's website at www.planetary.org. LightSail-1, the Planetary Society's new ultralight CubeSat-based solar cell spacecraft, has passed its critical design review. At a two-day meeting in Pasadena, a team, including JPL project veterans Bud Shamir, Glenn Cunningham, Victor Zerzanovich, and Aerospace Corporation's Dave Bearden, reviewed the LightSail-1 project from soup to nuts and gave us the thumbs up to proceed with building the spacecraft's hardware and software. Cunningham said that the design and development team looks outstanding, and that the review presented some excellent work for the team. He and other reviewers made some specific recommendations concerning risk identification and management, and suggested additional analysis that might be helpful. Our 4.5 kilogram spacecraft is an amazing advance in technology, analogous in my mind to the miniaturization of computers 2 decades ago. LightSail-1 has 10 solar cell panels, 4 deployable arrays with panels on each side, plus 1 panel at the top and 1 on the bottom of the spacecraft. 2 2-megapixel cameras mounted at the end of 2 of the solar panels. Only 1 camera is visible in this diagram. 4 sun sensors mounted at the end of 4 of the solar panels. 6 tiny ultra-sensitive accelerometers that will provide a direct measure of light force. This is the same light force that's used to propel the cells themselves. A momentum wheel for attitude control, colored red in this diagram. 3 single-axis gyros, which is in yellow. 3 torque rods in gray, also part of the attitude control system. And a battery, which is salmon colored, looking like a laptop computer battery. Now, below the empty space where the solar cell is stowed for launch, there are 4 new deployer mechanisms invented by our team around with the track booms were wound. The cells themselves are 4.5 micron mylar film, aluminized and seamed for ripstop protection. The thinnest cell ever made for spaceflight. It will provide a total area of 32 square meters. That's 5.6 by 5.6 meters. At the top of the spacecraft is the slim avionics package consisting of the command, control, and data handling circuit board, the payload interface board, the radio transceiver, and power regulator. And at the bottom of the whip antenna is the whip antenna for UHF communications, not just to our specialized tracking and command stations, but to the whole world. All of this capability could fit comfortably into a carry-on suitcase. Each of these components represents advanced technology, but it is more than the manufacturing the spacecraft that makes LightSail-1 a big undertaking. We also have a required system and engineering integration and testing and the software programming of the circuit boards that serve as the spacecraft's central computer, or its brain. We will complete the building and the spacecraft by the end of this year. But to increase our reliability and quality assurance, we have stretched out our integration and test schedule so that it runs into the first quarter of 2011. We will be ready to launch in the second quarter of 2011, and we are now evaluating several options for launch, including a piggyback on a NASA launch, Air Force, other national security space agencies, and possibly a foreign launch. We expect to have a firm decision on the launch within a couple of months. Our launch requirement is more difficult than many other cell spacecraft concepts, as we insist that we must launch high enough to render atmospheric drag negligible. A minimum altitude of 820 kilometers is necessary for pure solar cell flight. One very important aspect of our solar cell team is its mix of experience and youth. Stellar Exploration Incorporated, led by Tomas Savitek, is where our spacecraft is being built. They work closely with the avionics team of California Polytechnic University, San Luis Obispo, or Cal Poly, who also supplies the basic CubeSat bus and the launch vehicle, the P-Pod, interface. The mission operations team is centered at Georgia Tech University under the direction of our mission manager, Dave Spencer. Primary mission control will be at Cal Poly with backup at Georgia Tech. The project manager is Jim Contrell of Strategic Space Systems, and I, referring to Lou Freeman, is the program director. Now, that was an article recently written by Lou Freeman back in June regarding the success of this review. Now, this is like I say, this is a huge step into the future of the development of this program, due simply to the fact that it covers a lot of the safety concerns that had been an issue with Cosmos 1. So hopefully in 2001 we will see a launch. If you want to continue to be updated on the success or the development of the LightSail-1, please go to planetary.org and check out the spacecraft in the projects project section of the website. This was Errol Coder, and you've been listening to Planetary Television. I'd like to thank you for joining me, and as always, keep looking